Well, I can't help it. I've been thinking about Ender 3s again. What's up everyone, Chris here, back again in the basement, and over a year ago now, we did a video series on the Ender 3. The whole point was to start from scratch, get it assembled, do a few upgrades that were very cost effective, maybe even no cost, and then we would work on a slicing profile to try to get the best print possible on a budget printer. But the whole point of that video series was to not spend a lot of money on an already low-cost machine. You don't want to do a lot of upgrades that you might not have to. And I started thinking about it again, and I was also forced into an upgrade because I did have a failure on this printer. So I thought it would be a great time to jump back into this subject and continue on with that series a bit, just to see if we can improve this 3D printer and get it back running once again. So let's start with the extruder and what happened on this printer. So this is my second Ender 3. This is the one I bought specifically for this video series, so we could walk through all the steps. I haven't changed anything since we did those videos. I have, however, used it a lot. I've even got a tear in the bed right here, but it has seen a lot of mileage, and it's showing some wear. I went to use it the other day, and I noticed that the extruder was skipping, and it wouldn't grip the filament anymore. So I got to digging around, and I found that we had a break on the extruder arm. And the extruders on these printers are just these plastic plates. This goes down over the motor has the gear on it, and then you have an idler arm that pinches the filament up against that gear. It is very common to see fractures on these arms, and you might not even know it. So if you're seeing under extrusion, this is definitely the first place that I would look. If you take a look at the back of this, around that brass insert is completely split. So that's not going to allow you to press up against that filament like you should. And that is probably a very, very common failure on an Ender 3. A lot of Creality machines still use this plastic extruder, but it's also a very low cost upgrade. And I really don't think it's worth spending a ton of money on an extruder for an Ender 3, especially if you want to stay in that low budget range. But there's a lot of options out there under 10 bucks. And this is the one that I decided to go with. It's a direct copy of the plastic one here. It's just made out of aluminum. I'm not exactly sure who made this one, but I found it on AliExpress for $6 and some change. And this is really all you need. You can keep your stock gear, just switch out to some metal parts so you don't have failures like that and you don't have surprises. It goes together exactly like the stock design. And because on most of these designs they're very similar to stock, you probably won't even have to adjust your gear, but definitely check it. But that stock extruder housing holds the motor in place on the back of this bracket. So the motor sets just like this. Then your new aluminum plate will set right here. In your kit you will get a larger countersunk screw to go over on this side. This allows that idler arm to move properly. Then you get a couple of button head screws, one right here, and then one back here on the other side of this coupler. Then your spring will set on this bottom screw here, and then fit on the button head screw that's in your idler arm. There's an insert that goes in the idler arm. That's to allow it to spin a little better. You can force it on. Be careful, this is a spring, it can get away from you. And then you'll have a cap head screw that holds on the arm assembly. And you don't have to get this too tight. Make sure everything still moves freely, but you don't want anything to move up and down either. And then put your Bowden tube back on and you're good to go. I did reuse the couplers that I got from Capricorn just because they're a little higher quality. So that's a really simple upgrade that's going to add a lot of reliability over time. And again, there's a lot of great extruders out there. The EZR comes to mind from Semi CNC, but it's still around 30 bucks. And I don't think it's absolutely necessary to upgrade your extruder to get really good print quality out of one of these low-cost machines. Now, flexibles and things like that are going to be easier on different types of extruders, but most of us, especially beginners, hobby-based printers, they're only printing things like PLA and PETG. And I don't think the print quality bump just upgrading this extruder was much, if any at all, but I did go ahead and redo one of the prints from the last set of videos just to see the comparison. And it might depend on when that extruder arm started failing, who knows, but I didn't see a lot of change. Here's a comparison print. This is a 50% size orc that Vedran did. This is a very challenging print, but this is the one after the extruder upgrade, this is the one before. And it's kind of a mixed bag here. Some things are better on the before print, some things are better on the after. But nothing that I would see that was probably caused by the extruder upgrade. I did have to adjust my E-steps a bit. I moved from 93 to 100. And anytime you make an extruder change, you're going to have to calibrate that. Check out the video before this one. I'll leave a link to calculating E-steps. But again, this one was done when the printer was a whole lot newer. And that got me thinking about wear and what I would change as the printer ages to make it print better. There are a couple of lines down in here on the print after the extruder that are very suspect. So I've been thinking a lot about maintenance on 3D printers lately. I did a bearing video not too long ago. But that got me thinking about this machine and what would I change out if I wanted the print quality to increase, and what is maybe one of the weak points on a machine like this. And then I started focusing on the V-wheels. So on i3 machines and a lot of different 3D printers, there's two really common ways of moving things around. You can do it with smooth rods and linear bearings, or you can also do it with V-wheels on extrusion, like this here. This is a very common method for budget 3D printers. And they use that method on a lot of different types of machine. But I've had a lot of these printers before that have this type of setup, and almost always I see some wear on the V-wheels at some point. And in Ender 3, you have 3 over here, 3 over here, 3 on your extruder carriage, and then 4 on the bed. And when you buy one of these 3D printers, that's one of the first things you want to check. You want to make sure that all the wheels are adjusted properly, everything's lined up, so you don't have any problems. But in that process, sometimes you can cause some issues if you make them too tight, or maybe you have a wheel that isn't quite right from the factory. And that will cause issues down the road. It's very common on the beds to start feeling just a little bit of thump when you're rolling it back and forth. And that's not going to help your print quality any. Let's just take a look at the Y wheels on this printer. You can see the wheels under here. When I adjusted these to get enough slop out of the bed carriage, I probably made them just a bit too tight. The extrusion is actually eating some of that wheel off. You can see the particles that it's left down in this track. And who knows what caused it? Maybe the screw wasn't quite straight. Maybe the wheel wasn't exactly round. But whenever I adjusted it, that's what I had to do to be able to get it to work correctly. But that's not going to keep going the same way over time. You're going to see wear. So there was my next stop on this train of thought. The wheels that came with this printer probably weren't very high quality. They might have not been that round. Maybe the bearings weren't working all that well. So I thought, where would be a good place to go get some high quality V-slot wheels? And my first thought was OpenBuilds. And I was a little taken back by the price. There are 13 wheels on an Ender 3. Remember, the Ender 3 cost around $180. You can even get it for a little less than that. So you can get the replacement wheel and just use your bearings, $250 each. What I would recommend is getting the whole kit, because the OpenBuilds bearings are going to be a lot better, and they have actual shims with the kit. That's $519 each. And if you have to buy 13 of them, that adds quite a bit of cost to this printer kit. You can also go with the Extreme wheel. They are $7 for the kit. These might be just a little bit more accurate, and they're probably more heavy duty, but you probably don't need those on an Ender 3. So, ouch, right? Almost $70 for a full set of wheels for an Ender 3, and you're going to have to pay some shipping. But if you look at it this way, this is actually just a maintenance item. You will have to change out these wheels eventually. And you could also do it a little bit at a time if you wanted to. I always see the Y carriage wheels wear out first. So maybe start there, grab 4, see how it goes, and then you might want to continue on. It is a bit pricey, but I think it needs to be done. So that's what we're going to do today. We have some prints before, we're going to upgrade all the wheels on this, then we're going to do some prints after, just to see if it makes any difference, and then you will have just a bit of peace of mind knowing you got this upgraded, and these are the highest quality wheels you can probably get. So let's take a look at the wheel kits. So here's the solid V-wheel kit. You get the wheel, 2 bearings, 2 shims, and a nut if you need to install them. The bearings will just pop in. You should be able to do it with your hands. Then you throw a shim in the center. And then you put your other bearing in. Easy enough. But they're very nice wheels, very hard. And knowing OpenBuilds, they're nice and accurate, and you get a nice bearing. The bearing is a 625 RS. They're self-centering, self-lubricating. You shouldn't have any issues with these. And if you want to go super high-end, you can go with the Ultra wheels. These are really, really hard, but they're set up the same way with the same bearing. You just throw them together, put your shim in the middle, and you're ready to go. They might even be just a bit lighter than the standard plastic wheel. So if you really want to go overkill, if you're that type of person, you want to do this on an Ender 3, you might want to look at the Ultra wheel. I don't think you need it. These black ones are made of Delrin. These are made out of hardened polycarbonate. So it's going to be a little bit lighter, probably bulletproof. But for today, we're just going to go with the Delrin wheels and replace them. So I'm just going to start by pulling everything apart here. I'm just going to take the bed off. We'll just remove the wheels. And then the heated bed will just lift off. We'll move the X up a bit. Don't lose your springs. And you can just unhook your belt. You might have to retension it here. Loosen up a couple of screws here in the front. And then we'll just remove these 4 nylock nuts. I just use a socket on top. You can usually just hold it with your hand and then back those screws out. Remember, 2 of these have an eccentric nut on it so you can adjust them. So 2 of them have a washer on top, up here, so don't lose that one. And then you can remove the screw-in wheel. And after you get one side done, it's a lot easier because the bed can be removed. Then we'll just take off these other 2. If you take a look at the stock wheel, you can see how some of that coating is starting to come off. And you can see how it actually is beginning to wear. You can see it down in here on the sides. Some of them, it's really not all that even. The rail's cutting into that wheel. And that is a 6255ZZ bearing, just for reference. It does seem to turn pretty smooth, but not every bearing is going to be equal. I thought it would be interesting to measure some of the wheels. This is the stock one I just showed you. It's coming in at a little over 24 millimeter. About the same for this one. Again, another stock wheel. And again on this one. So the tolerance on these is at least pretty close. And all of the OpenBuild wheels that I measured come in just a little bit over 23.9. Again, they are all also very consistent. I measured a ton of them. On average, the polycarb wheel, the tolerance is just a bit tighter. So one of the key things to consider if you're going to replace these or do any type of maintenance on a printer like this, you need these rails to be clean. So we want to wipe these down and maybe put a little light oil on them before we replace the wheels. Use something that's lint-free like microfiber. Because any little particle that's in this channel might cause a print artifact. You never know. So I'm just going to use a little bit of alcohol because that's what I had on hand, just to wipe them down, make sure I get in these channels really well. Make sure they're nice and clean. Then we can go ahead and put everything back together with our new wheel. When you're putting these together, note that you shouldn't need a shim on this side or the collar side because that screw head lines up with the center really well. It's going to allow the bearing to turn freely as well as that collar. Same way on the side with the eccentric nuts. Most of these have a little lip on the bottom. This gives you enough clearance. You don't have to worry about it causing any issues with that bearing spinning. Now we're ready to go back together. You'll notice on this plate, there's a couple different sets of holes. I'm guessing that's so they can use them on larger machines that has like a 40-40 for the Y, like on the V2. But you're going to want to use the inner holes. I like to keep the eccentric nuts, the adjustable side, on the right side of the printer. I think that's the stock location. It is a little bit different left and right. So the two for the eccentric nuts are going to be right here, and then the two with just the standoffs are right here. So the standoff side, screw, then wheel, then standoff through the plate, and then nylock nut. And you don't have to worry about getting these really too tight. Get them good and snug. You don't want to move it around. Because of how those bearings line up, you don't have to worry about that screw impacting how it spins. We've got those two on. Now we'll move to the one with the nylock nut. On the nylock, screw, wheel, then the nylock nut with the longer piece sticking out, that goes into the plate. You can see on this side it's just a bit shorter. That does keep it from interfering with the bearing, so you should be good. Then I'm just going to loosely put it on the plate, and then we'll have to put it on the printer. Before we do that, put your washer up above here. That helps you be able to adjust that eccentric nut. Leaving that loose, I can slide it on the rail and then tighten it up. And same for the one on the back. Now that they're on, we can go ahead and adjust those eccentric nuts. Those are 10mm. You want them to be equal, and you don't want any slop in that carriage. Try to get them equal distance front and back, both of those wheels, from that extrusion. I would torque them down just until you can't feel any movement. Back them out each just a little bit until you can. Just a little bit of movement. Put them back in, no movement. And then do the same with the other one. A little bit of movement, no movement. That's just the right amount, and you want them to be equal. And then just test the whole thing with your hand. And that is a really smooth motion. No bumps, nothing. Very nice. And at this point, if you want to, you can put a little bit of lubrication on here. I recommend something like this, just a very light synthetic oil. Don't use much at all. In fact, usually I just wipe a little bit on the V-groove with my finger and let the wheel work it in. For Delrin, that probably isn't even necessary. And then we can go ahead and reverse the steps and put the bed back together. Bed's back on. Let's go ahead and move to the X. And this is the order of criticality, I would say. Do Y first, then move to X, then Z. That's probably the order that you would see the most improvement. The camera always focuses on that coffee cup. Anyway, so we're just going to repeat the process. We will remove the carriage. Two static ones on top. Probably have to use a ball-ended wrench on this one over here because that coupler is in the way. You can kind of get around it. Not a huge deal. Or you can just take the coupler off if you want. That'll free up the carriage. Probably don't even have to take your belt loose. You can just leave that screw in there as well. And on the bottom one, the screw head actually faces this way. And that's the one that's adjustable with that eccentric nut. And that bottom one you'll probably have to go ahead and remove, or at least loosen up your fan shroud to get that out of there. But that shroud is just two screws, no big deal to take it off the front. Then you can just use your 8mm wrench to grab that nut on the other side and back it out. Not as much wear on these X wheels, this is the bottom one, but there is still some. So on this one it's just a bit different, but you want to do your screw, then your new wheel. That goes into the eccentric nut with the shorter lip on that side. The longer one goes into this metal piece right here. Slide it through. Then on the other side, you want to put your washer and then your nylock nut. And then we can go ahead and snug that one up. We'll move to the top ones. We've got the screw, then the collar, then our new wheel, then the nylock nut. We'll get that one snugged up. Same process for this side. Now we're back together. Go ahead and put my fan shroud back on here. And same process for adjusting this one. We want to make sure it doesn't have any slop. That's actually pretty tight already. So I'm going to take it to where it does have some. Move it in a little bit at a time until it doesn't. That's good right there. And then I like to recheck. Just back it out a bit until it has a little slop. And tighten it up just enough so it stops moving around. That's good right there. We need to go ahead and clean this rail up too. Same process. I use just a little bit of alcohol to get some of the grease off. Bottom and top, make sure there's no debris. It's nice and clean. It's running nice and smooth. And again, if you want, you can go ahead and put just very small amounts of oil on the V part of these rails. A lot of times oiling things like this will actually collect more dust than if you just left them alone. So be careful with what you use and how much you use. Now we can move to Z. So now Z is, in my opinion, is probably the one that's the biggest pain to switch out wheels on. Not so much this side, those are open. It's all about this one right in here. It's behind that extruder motor. But there are steps that you can take to get it all apart without having to disturb your X gantry too much. So I'm going to go ahead and remove this extruder motor one more time. We'll just set it aside for now. That should give you access to this nut. You can actually go through this piece of extrusion, there's a hole in it, to get access to the head to this screw. So you'll have to use a wrench, but then you can back this out. So you'll take your nylock and your washer off, but the screw is sandwiched in there. So you can't get your eccentric nut out and your collar to replace that wheel. So I just remove these two wheels over here. So we'll take this top one loose. These do have two different collar spacers in here. Try not to lose them. They will fall out. Then same for the bottom one. And then when that's unhooked, I'm just going to loosen up the coupler for the Z-rod. We only really need to loosen this top one here. And then we can just kind of lift this out of the way. Now we can swap out that wheel. That's a little more than I like to remove for this operation, but it is what it is. We'll just leave that collar in place. The screw's not going to come out. And we'll slide on our new wheel. The eccentric nut, remember the longer section needs to be facing out. And now you can go ahead and just put your plate back on. Then washer, then nylock nut. I'm going to go ahead and put on the other two before I get that one snugged up. You can go ahead and fasten your Z-rod once again. We won't have to take that apart anymore. Make sure it is down in that coupler. And on these two, just to show you how this works, screw, bracket, collar, new wheel, then collar, then bracket, then nylock nut. Same way for the one here on the bottom. Now that all three are on, you can go ahead and snug all these up. Remember, you can go ahead and get them pretty tight. It shouldn't interfere with that bearing. Now we can go ahead and put our extruder back together. We don't need it for the other side. Before I adjust that eccentric nut, I'm going to move the other side and do those. Then we'll adjust them at the same time. Now over to this side, pretty much the same sort of deal, only we don't have to deal with that extruder motor. And over here you can just do them one at a time because we don't have to remove the plate. So we can leave some of this stuff intact. So we don't even have to remove the eccentric nut here. We'll just slide our new wheel right back on and put our nylock nut right back on. Same way with these two outer wheels, you can just lift your X carriage above that PSU so it's easier to get to them. And we'll just replace them one at a time. So screw, new wheel, collar, through the carriage. Nylock nut goes back on. Exactly the same for this bottom one. All the new wheels are on, we'll go ahead and adjust the nuts. On Z, I've shown this process before, but since you can't tell if there's really any slop in here, unless there's a lot, I mean, you could move this whole gantry if there was a lot of slop in there. But the easiest way is just to move this up and down by hand and get this inner wheel just tight enough and make sure all 3 wheels are turning. You don't want to be able to stop them easily with your finger. But you don't want them too tight because that might cause binding. I like to start with this side. You can kind of judge with your eye, loosen this up until you see it pull back from the rail just a bit. Just a tip, it's actually easier to see the nut move on the back of this plate than it is the wheel, if that helps you at all. And we'll just move up and down a little bit, test all the wheels. Make sure they're not easy to stop with your finger. And even on the loosest setting, mine feel pretty good. Same way with this side. This side's a little bit looser. I can actually just turn this one freely on the inside. So I'm pretty sure it's at the loosest setting. We'll start by just getting it tight enough so I can't turn that one. And we'll test these other 2. This one at the bottom is a little easy to stop with my finger. Tighten it up just a little bit more. And now we're in pretty good shape. This side's pretty important because you can introduce slop in this carriage if it isn't tight enough. Remember, not too tight, but you definitely don't want the wheel to be easy to stop. And then after you get that one done, go back and check these 3 again, just to make sure everything is nice and snug. And after that, I'm going to go ahead and clean the outsides of these extrusions as well. Same thing, a little alcohol. Move the gantry up, and I'm going to go ahead and do the lower sections as well, just to make sure there's no debris in there. Make sure everything is turning nice and smooth, no problems at all. And again, if you want, you can put just a little bit of oil on those extrusions. And the wheel swap out is complete. So we did have just a bit of wear on our V wheels, and by replacing them, at least we'll get back to stock condition, hopefully better, because these should be higher quality wheels. But we'll find out. Now remember, you took your machine apart. There's a lot of things that we did. We retensioned some belts. Go through and check and make sure the machine is okay, we didn't miss anything, and if you're going to upgrade, especially something like an extruder, you're going to want to go recalculate your E-steps, make sure your extrusion's right, maybe even your extrusion width. Just check a few prints to make sure everything's okay. Now is also a great time to either swap or clean out your nozzle to make sure everything is flowing correctly. Now, pretty much all we got to do, adjust a few things, and then try some test prints. And here are the results. This is the one I did just after the extruder upgrade. This is the one after the wheel upgrade. And I'm sorry to say, there's almost no difference in between the 2. I was hoping to get a little bit more accuracy from moving to the new wheels because there was a lot of wear on the old ones, but you just can't see it in the print. So I still think it's worth your time upgrading these wheels if you see wear, because you will have to eventually, but don't expect it to cure every little print issue right off the bat. So we did a bit of an upgrade on the extruder. That should make it more reliable over time, and a bit of maintenance by swapping out those V wheels. Unfortunately, we really didn't see a lot of change in print quality. It didn't improve, but that's okay. That's what testing's all about. And now that I know going forward we have a really solid set of wheels on this machine, that will help as we add upgrades down the road. So hopefully you found this interesting. There will be more Ender 3 content coming, but that is it for today, and I'll see you very soon on the next one.